So as per the question, there is a uniform ring of radius r and m mass per unit length. So the linear mass density is m, mass per unit length. Okay, so we can write linear mass density mu is nothing but m here. Understand, m is not a mass per unit length. Okay, and it is rotating with an angular velocity omega. Okay, so this is rotating with an angular velocity omega like this. The increase in the tension due to the stretching of the ring is proportional to. That means when it is when it starts rotating, tension will be developed in the ring. You have to find out the tension in the ring. And why would there be a tension? See, if you take any small section of the ring, and you can see it's like a point particle rotating in a circle. So for that it requires a centripetal force. So there must be a centripetal force, and this is provided by the component, the resultant of tension acting in the wire, and tension at that section will be pulling on two sides. So this is how tension will act on the wire, and the resultant of the tension will become the centripetal force. That's how you solve it. So to solve this, we will consider a small section here. This is a small section of the wire. Okay, and that makes a total angle here, and these angles are separately taken as theta. That angle is taken as theta, this is also taken as theta. These are extremely small angles. You can even take them as a d theta. Okay, now that section of the wire requires a centripetal force in this direction. So the required centripetal force can be written as, if the mass of the section is dm, then you can see dm omega square r is the centripetal force required. Okay, since you are taking dm, it will be better to take the angle as d theta. Okay, so total angle is 2d theta. What is the length of this wire? Length of that wire is nothing but, use the concept of angle. Arc length by radius equal to angle, or arc length is the length equal to r into d theta twice, 2r d theta. This is the length of the arc. Now what is the mass of that one? Mass is linear mass density into length. So that will give you 2mr d theta. So this becomes the mass of the section. Now where is tension acting? Tension will be acting tangentially like this. So this is tension, and this is also tension. Now you need to find out the resultant of the tension. Now tension will act tangentially. So this is how tension acts on one side, and this is how tension acts on the other side. Okay, now resolve them. Resolve that into two components. We'll see that for that we can draw a tangent here, and this is the normal, and the angle created by the tangent, because we have taken a small element at an angle d theta. This was a small element. Since the small element is making an angle d theta here, this is d theta. So this angle will also be equal to d theta. This angle is also equal to d theta. So tension will have two components. Okay, tension will have two components. One component towards the center, and the other component tangential. This component will be t cos d theta. This component will be t sin d theta. Similarly, tension on the other side will also have one component towards the center, which is t sin d theta, and the other component will become t cos d theta. And you can see the cos component will cancel each other, but the sin component will add up, and the sin components will give you the total resultant force to the center, and the resultant force is nothing but 2t sin d theta. this should become the centripetal force. Now our solution is complete. Now what to do? Find out substitute and calculate. So the final steps are like this thing. 2t sine d theta is the resultant tension, component of the tension, and this should be equal to the mass which is rotating is dm, its radius is r, dm r omega square. That is the required centripetal force. But we already proved that dm is nothing but 2mr d theta. So substituting, you will get 2t sine d theta equal to 2mr d theta into r omega square. But see, angle is very small, therefore sine d theta can be written as equal to d theta. So the final step will be 2t d theta is equal to 2m r square omega square d theta, from which you can find out this 2 and 2 cancel, d theta cancel, so you will get tension equal to m r square omega square.